Hello, it's Dr. Kofelt again. We're ready to start on part 2 of the first chapter of chemistry, which is going to cover the scientific measurements. So we're going to look at some SI units, that's the International Standards units, and their symbols, and we're going to use those SI unit prefixes. We're going to perform conversions between temperature scales, because in America we use Fahrenheit, which is different from pretty much the rest of the world. And then we're going to apply derived units, and such as things that you're calculating. That's what we mean. So when we derive them, we use volume, density, things like that to perform calculations. All right, let's get started. So the SI units are those scientific based units that everybody agrees that these are the standards, okay? Now, a lot of them are the ones we use, but like meter, for example, we do. But kilogram, we typically use grams because grams are more manageable. They're a smaller amount. So seconds, yes. Electrical currents, the amp or ampere. Kelvin is the standard scale. Okay, and so we're going to have to learn how to convert to that. Moles are the amount of substance in something, and then a candela, which is the luminous, which we're not going to use too much in this class. So prefixes that are used with SI units, the nice thing about the metric system and the SI units is that they're all multiples of 10. So if you're familiar with exponents, you can see that 10 to the 12 is how many spaces there are past that 1. And so you have one number at the beginning, and then 10 to the 12, as you can see, it's I don't know what that is, terabillion or something. Then giga is 10 to the 9. 10 to the 6 is mega. These are getting down to the ones we use. Kilo, you will see quite a bit. And then the small ones, decigram, centigram, milligram, microgram, and then even nanogram. But pico, you're not going to see very often in this class as well. So you are going to be using exponents in this chapter. So if you need to have a refresher on those, try to find a math refresher on exponents and just kind of go over that again. So mass is the measure of the amount of matter in an object, and the kilogram is the SI unit. There are 1,000 grams in 1 kilogram, or 1 times 10 to the 3. That 3 comes from the fact that if you start here where the number ends, you go 1, 2, 3 places. And so if I write it 1 times 10 to the 3, that means that you would take that number and add 3 places and get back to the 1,000. Temperature is a measure of heat, and there are 2 temperature scales that we use in chemistry. One is the Celsius scale. It's originally defined and very easy to use in the lab because 0 is the freezing point of water and 100 is the boiling point of water, so it's a very convenient scale. But the SI unit of temperature is the Kelvin. And the Kelvin is called an absolute temperature scale, meaning that the lowest possible temperature ever is 0 K, okay? And so we call that absolute 0. And you'll notice we don't use degrees with Kelvin since it's an absolute scale. Units of excuse me, Celsius and Kelvin scales are equal in magnitude. So a degree of Celsius is the same as a degree as a Kelvin unit. And so Kelvin is equal to degree C plus 273.15. So a very, very easy conversion. And if you need to go the other way, if you want to do degree C, that would be what? Kelvin minus 273.15. Very, very simple. All right, so normal body temperature can range between 36 and 37 during the day, and that's degree C. And it wants you to express those two temperatures. And so, as I said, all you would do is you would add 36 to 273, and here we just kind of truncated it a little bit to get 309, because if you're 300 degrees, 0.15 doesn't make a lot of difference unless you're a rocket scientist. 37 plus 273, 0.15, whatever, is 310. Okay, so 310 Kelvin. All we did was add that 273.15. So how this works is I do one of these problems, just like that simple one that I just did, and then you are going to do the for practice problems. And so work those out. You can work them on these sheets. You can work them on your in-class sheets that are provided as a study guide for this chapter, and you can also use the problems. We have just the problems printed out too. So, but if you're turning anything in for bonus, if you're in a class where this is for bonus, then you make sure that it's the whole thing with all the fill in the blanks and everything. All right. So we said the temperature is Celsius and Kelvin. That's what we're going to use in science. Unfortunately, in the United States, we have not gotten away from using Fahrenheit. And because of that, we have to do a little more difficult conversion. And you either multiply by 9/5 or by 5/9, and I'm going to show you how that kind of relates to easier. I know a lot of people don't like fractions, but there is a slightly easier way to do this. Okay, so the body has a temperature of 39 degrees Celsius, which is a high fever. Convert this temperature to Fahrenheit, and if you recall, Fahrenheit is equal to 9/5 or 1.8 times the temperature in Celsius, and then plus 32. And I always remember you're going to add that 32 at the end, because Fahrenheit is going to be a higher number typically. So you've got 39 degrees C, and you want to convert that to degrees Fahrenheit. Okay, so degrees Fahrenheit equals 9/5 or 1.8 times the temperature in Celsius, which is 39 degrees C, plus 32. Okay, so degrees F is going to equal 70.2. Just multiplied those two numbers together, plus 32. So degrees F will be 70.2 plus 32, or 102.2. And then we're going to look and see where do we need to be in, if we have the right number of significant figures. And the last thing that we did was add. This one is considered to be like a conversion factor, so it has an infinite number. So since this one had 1, then we are going to have 1 decimal place in our answer. And then there's your practice. Okay, and this time you're going to Celsius, so you're going to rearrange that a little bit. Since you're multiplying by 5/9, that's the reciprocal of 1.8. So if you were going to use the 1.8, you would just divide by 1.8 here instead of using this. So you could also use degrees Celsius equals Fahrenheit minus 32 divided by 1.8. And you can use that formula instead if you like. So we also have, have derived units, volume and density, and there are lots of things that are derived units that are not included in the SI base units. And so in these cases, we combine base units to derive these appropriate units. Now, don't get excited. We're not going to do calculus. It's not that kind of derivation. But the derived SI unit for volume is the meter cubed. And it's a larger volume than most of us are ever going to see. It's a very, very large volume. So we typically use cubic centimeters. And this is just kind of showing you where this derived from. Because this is so large, that's not practical to use in a laboratory. And so we can take a tenth of it, and a tenth of it would be a cubic decimeter. And so it'd be that little block right there. More often you're going to see the cubic centimeters in our class. So derived units include density, and so derived units is kind of another way of just saying using formulas. So in this case, density is equal to mass over volume. Typically, you're going to see mass in grams over cubic centimeters, as I said, or grams over mLs. Notice this very important fact, that 1 cubic centimeter is equal to 1 milliliter. That's very, very important. Put that in the back of your mind, because when we're starting to do calculations, that's going to be super important. So ice floats. Ice floats in a glass of water because solid water is less dense than water. That's why it floats, even though it should be heavier because it's the solid form, right? So we're going to calculate the density of ice if it's at 0 degrees C, and it's got 2 centimeters on each side and has a mass of 7.36 grams. So why are they telling me that this cube has 2 centimeters on a side? Because the volume of a cube is sides cubed, okay? So we call that like a cube, and I'm not an artist, you'll find that out pretty quick. But let's say this is my cube and we have 2 centimeters on each side. So we have 2 centimeters times 2 centimeters times 2 centimeters equals 8 cubic centimeters, okay? Or 2 centimeters cubed. Just remember when you're doing these, you've got to cube that unit as well, okay? And anytime you're doing that, that 2 will be cubed, and also the centimeters will be cubed in order for you to get your volume. So this gives us our volume, cubic centimeters, all right? And it can be in that, and a lot of times in solids, we use cubic centimeters to do that. All right, so our mass, we said, is 7.36 grams. So we've got 7.36 grams, and we've got a volume of cubic centimeters, okay? So 7.36 grams divided by 8 cubic centimeters is going to give us 0.92 grams per cubic centimeter, okay? Simple, right? You just had to know an alternate way of calculating the volume for us to use. Okay, in the second question, it says, what's the volume occupied by 23 grams of ice at 0 degrees? So this time, we just calculated the density, right? So for this problem, we know now that the density is 0.92 grams per cubic centimeter, okay? And the mass is going to be 23 grams. So our density, which is 0.92 grams over cubic centimeters, is equal to 23 grams over V. Okay, and so I'm going to have to rearrange that. And so if you remember, you're going to multiply both sides by V, right? So that's going to give us V here and V here, all right? And then to get rid of the 0.92, you're going to cross multiply or divide both sides by 0.92, all right? Now, that gives us, as we end up with, the volume of, I'm sorry, I'm looking. Okay, they're in, I'm back. Okay, so that's going to be 23 grams divided by the density, which is 0.92 grams per cubic centimeter. And that's going to give us 25 cubic centimeters, or 25 milliliters, because we know those are the same. Okay? Sorry, a little messy. I hope you get the idea. There is your practice, where you've got 25 milliliters of mercury, giving you the mass, and you find the density of mercury, and then once you've got the density of mercury, you can find the volume if you've got 155 grams. And you might find it easier, like if you've got a formula like this. There's two ways to do this. You can do it like I just did it, or you can rearrange the formula before you start. So if I was going to solve for V, I know that you cross multiply, right? So VD equals M. And then you want to get V by itself, so you divide both sides by D. And then you will have volume equals mass over density. I kind of like to do that, to rearrange the formula, and then you can solve for whatever you're looking for. It's up to you. Anyway, that's it for part 2. I hope you enjoyed it. Hopefully you'll come back with me next time in part 3, where we're going to look at the physical chemical properties of matter.